Since underwater silt and sediment are often the final resting place for toxic waste that is washed down from industrial sites, modern dredging can have dire consequences if the right precautions are not taken. The massive deepening project in the New York-New Jersey harbor impacts several areas that contain toxic materials. For decades, industrial waste trickled down the Hudson River and its tributaries, creating a dangerous layer of contaminated sediment in some parts of the New York-New Jersey port.
This New York Harbor, New York area, of course, was very heavily industrialized in the turn of the century. And we're dealing with that industrial legacy right now.
Being the top layer of silt sediment material in the bay, and being that this is a very industrialized and urbanized bay, this top layer does have contamination in it.
While the backhoe dredge does a superb job grinding out the hard rock sections of the New York-New Jersey port, other areas of the harbor call for a more delicate approach. Specialized equipment must be used to ensure the dredge operations don't release toxins back into the environment. The Michigan is what's known as a clamshell dredge. This clamshell bucket has been modified into what's known as an environmental bucket, designed specifically for handling light sediment and utilizing special rubber seals to keep spillage to a minimum. As the bucket is raised, its speed is also controlled to reduce the amount of overflow.
Candidly, dredging, although it's a technological challenge, is actually the easier part of a program. The most important program is where is it that we take the dredge material and what it is we remediate, and will it be acceptable?
One of the ways to render the hazardous material into a form that can be used safely is to mix the sediment with Portland cement. Portland cement is a compound that not only hardens when mixed with water, but also becomes water resistant.
In the treatment process with the cement binds the sediment particles together, and in that process entraps any contaminated material. It's typically heavy metals, binds that within the cement so it doesn't leach.
The mixture will remain stable over time and can be used to cover or cap land that may still contain toxic elements.
In this area, we're taking it to a couple of different sites. We have some park area that is being capped. They were industrial sites, industrial landfills, and they're being capped and are going to be made into a park.
The beneficial use of dredged materials also includes the rebuilding of areas lost to development and erosion. On the west coast of the U.S., the California State Conservancy has implemented a 50-year plan in conjunction with the Army Corps of Engineers to restore wetlands around the San Francisco Bay.
Most of the projects started in the 80s or the 90s, and they were relatively small, 50 acres here, maybe a couple hundred acres there. And now we've gone from that to one of the last major projects we did, Sonoma Baylands project, was 300 and some odd acres. And that was with the deepening of the Port of Oakland to 42 feet, a decade ago. And now this decade, we're deepening the Port of Oakland more, and we're doing a really truly landscape scale project. Hamilton Wetlands Restoration Project is currently 1,000 acres, and we're trying to expand that to 2,600.
It'll take about 20 years of maintenance dredging in the San Francisco Bay to amass the 25 million cubic yards needed to restore the Hamilton wetlands in San Pablo Bay, north of San Francisco.
You pump it in there, and then it comes out the end of a pipe, and by managing how you decant the water off the top, you make the material flow around to get the line and the grade you want.
Dredged material is also being used to restore ocean beaches. Beachfront construction and breakwaters have drastically altered wave patterns. This has led in turn to disastrous erosion on many sections of coastline.
In a situation where you don't have the sediments and you just have a seawall, large waves come in unabated, attack the seawall, and cause all that energy turns into turbulence in the nearshore zone and causes greater acceleration of the erosion. And so seawalls, although they do serve their purpose in the immediate region where they're put in, eventually we'll have nothing but an armored coastline.
The The Army Corps has placed dredged sand several hundred yards offshore the Ocean Beach area south of San Francisco, with the hope that natural tidal and wave action will deposit the sand back onto eroded beaches.
After they come into the nearshore area, they will bottom dump the sediments into a berm, which is parallel to the shore face. We hope to get about 1,000-foot long berm, maybe about 3 to 4 to 5 feet high, a couple hundred feet wide. And then the action of the waves will push that sand into the nearshore zone where it will widen the beach. And then it'll provide sediments when storms attack the coastline to form offshore sandbars and dissipate the wave energy through breaking.
Dredging contributes to land restoration, but the modern generation of dredges can also create brand new land. Mega-sized ports are the way of the future. In the Los Angeles harbor, the Pier 400 project created a 600-acre terminal for shipping containers, the largest such facility in the world. The job involved a unique partnership between the Army Corps of Engineers and the Port of Los Angeles.
The Port of LA's interest was to develop a harbor for commerce and to deepen it to 81 feet. Their objective met our objectives in that we needed a place to put our dredge material and they needed to have a landfill. So it worked out perfectly.
5 dredges, led by the Workhorse Florida, were contracted by the Army Corps to deepen the main channel to between 53 and 81 feet, deep enough to accommodate any ship in the world today. The massive scope of the work, combined with the heavy traffic flow in the harbor, gave the Army Corps a nearly constant headache.
You have about 3 to 5 miles of dredge pipe at times to deal with in an active harbor, one of the more active harbors in the world. We could not impede traffic at all, and maintain safety was a critical aspect of this job. So having to deal with floating pipe and then submerged pipe, moving it on a regular basis, was very challenging.
To solve some of those challenges, the Army Corps turned to its Engineering Research and Development Center in Vicksburg, Mississippi. The ERDC occupies 1.7 million square feet and includes an acre-sized simulation tank in which a 44,000 square foot model of the Los Angeles harbor was built. Experiments tested tidal action and the effect of wave energy on siltation in the harbor. It took 6 years of non-stop dredging to create a 500-foot wide channel that extended 3 miles out from the harbor into the open ocean. The Florida and other dredges scooped 60 million cubic yards of material from the ocean bottom and piped them onto a landfill, on top of which the new container facility was built. A small army of dredges is bringing the United States into the 21st century, well equipped to compete in the global market.